Hello, hello, people of the internet. Let's get the show on the road. Welcome back to another stream. This time pretty early on in the day. I bet this is almost like early morning or late night or something for some of you. Can't be helped. It is Monday here in Finland and I need to get some work done. And I figured I might as well stream this. So, welcome back if you have been following me for a while already, and welcome if you haven't. Today we're going to do a little bit of game development. I'm going to do programming, we're probably also going to do a little bit of modeling. Let's make sure we can run the game here. Right. So this is the current state of the gripper truck as it currently exists in the game. This is basically what it looked like at the end of the previous stream. Visually, not much has changed. We're going to start spawning test objects here. I think I put in like a delay there so that I have time to get rid of all the debug UI and everything if you want to make a pretty video. Anyway, this is basically where we were at the end of the last stream. But I've actually done quite a lot sort of under the hood to make this more robust. I had a bit of a jittering issue with the entire vehicle essentially. When the bed was connected the way it was, using a physics joint to the vehicle itself. And so I had to investigate a little bit why that was and tweak some settings. I think it's basically gone. I think there might be like some very small micro stutter, but there's almost nothing left. You can fly very close to this guy. And you can see some shadow acne there on the side of it, but that's not the physics. So it's looking pretty stable and solid right now. And that's neat. Another thing that I did was just refactor the code kind of extensively. If you saw some of my previous streams or streams from the past few days, there's things like, yeah, there's ever so slightly rolling that way and then falling off the world. You may have seen that I did quite a bit of head scratching there with the 3D math to get this kind of like articulated feature of the vehicle working. So we have this truck bed here which you can raise and lower like this, and it needs to sort of move around all the actors and everything according to that. Then we have these hatches here which are connected to the bed, right? So we have sort of like a hierarchy, a graph, if you will, of physics bodies that need to be sort of choreographed in a certain way. And I've been sort of hand-rolling that math for every single vehicle so far, because they've been sort of different, but not very different. So, for example, for the mother vehicle, the big one, spawn one of those in here. We have this crane here, which basically is the same thing. We have a hierarchy of things. The base, then we have this piece here, which is nested under the base. Then we have this piece here, which is nested under this piece. And then we have at the end we have this cable and the magnet and all of that. And it's also sort of a hierarchy. And it's all hand-coded currently, which it doesn't really need to be. So I made something that makes it a little bit more formal, should make it easier to make these kinds of like articulations in the future, hopefully at least. And so far this truck bed thing here is ported to use that system. But I think in this stream we will actually add the other articulated system on this vehicle, because it will have something in the front that allows us to lift things. So essentially it should be able to sort of lift things and throw them in the back of itself and then collect things that way. It's a pretty versatile vehicle, this thing. And so that's pretty cool. Before we do that though, I think I want to put in an actuator for the bed here, right? So let's see if we take one of these drawing tablets that I have lying around here. If you have the back of the vehicle here, and then you have the tilted bed, something like this, then there would be some sort of actuator here that kind of lifts this up like this, in the real world at least, like this, like a thicker part, and then there would be like a thinner part that kind of pushes into this, and then it sort of, as this goes down, this thing sort of like folds over like that. Something like that would be a pretty nice and fun little detail, I think, there to have. And I started experimenting with that a little bit. Actually, I have some commented out code here that we can put back in to kind of explore this idea a little bit. So now if we run this, I'm gonna go back. You see something is poking through there. So this could be essentially like the range of that actuator. So it would be sort of fastened down here, and then fastened up here, and then it needs to be able to get shorter or longer depending on the angle of the bed. So there's a little bit of 3D math involved with that. There's also going to be a little bit of modeling. I think we will actually probably start by modeling it. Right. So then we're going to just throw it in there. And I don't think we will actually put any physics into this. There will be no collisions for this actuator. It will be purely a visual thing. If something just falls down there and rolls through it, essentially it doesn't really matter. I think adding physics to it doesn't really, make the gameplay any better. It's just a small visual fun little detail. I already added this kind of like pit here for the actuator when it's sort of folded down, so it has somewhere to go essentially. But I think that would be pretty cool to have. And once we have that, I think we're done with the truck bed for the time being, and we can move on to the gripper arm, which will sit in the front and be attached to those weird holes there on the side of the chassis. How about that? That should be fun. So let's go into Blender, and this shouldn't be a very difficult thing to model. If Blender would start, thank you. So gripper truck concept. It's a bit of a stupid name actually, because this has been way more than a concept for some time now. So maybe we'll just call this gripper truck. Like that, and then we'll keep working with gripper truck in the future. So we can sort of rotate this guy, and we have these hatches nested underneath them, so they sort of rotate along with it. So we'll want to have some sort of fixture point here, up on the top, and I think we're going to do this quite simply just by eye. I just put in some random position there for the fixture point, but let's raise the thing. Let's raise the thing like this, and then we can have a closer look. right? So it's basically almost. Free camera is a bit fast. It's basically almost here at this edge is where it hits that thing. So we just add some kind of fixture here to it, and then I think this is the more interesting part. Where does it hit this thing currently, and is that a good position? It might not be, but it's like slightly below this line here with this. I don't know what these are even called. Support beams here. So if we do something like this, we take this guy. Oh, this is clearly mirrored. That works out just fine, actually. And we can just isolate that for a little bit. So let's add a bit of space there in the middle to actually have some place for that actuator to fasten to connect to. And then what do we do? Let's move this a bit closer there. Right, something like this, so then it sort of connects to that a bit more. I'm sure is needed. Actually, maybe we can just scale those individually. Whoop, like so. How about that? Does that look good? I think I want it ever so slightly more. Actually, I kind of like that. Let's do this. And then we can extrude this a bit more. Something like that. And then we quite simply bevel those a few times. Something like that. I don't exactly know what it's going to look good, but we'll start with something. And then of course if we want to, we can even put in like a small cylinder here to act as a kind of axle there. So rotate around, that would be Y, 90 degrees. Radius down, not quite that much maybe, something like that. Vertices should be pretty low, 12 maybe, or even 10. 10 is probably, I don't know, let's do 12. 12, and then depth is the value. And of course, this is again mirrored, so we'll want to actually remove that face, take that stuff and just move it to 0. And then quite simply just move this up by I. That might be pretty good. Let's rotate it so that it kind of is matching the rest of that, right? Something like that. I don't know. I don't know. Right. I'm not apparently doing any sort of smoothing here. I don't have a single smooth normal on this entire thing, but I would like to have smooth normals on that. So now the question is, do I like, what do I do? Shade this smooth, but let's put the angle down quite a bit. And then we raise it until that thing becomes smooth. It's not super important because we're gonna have to bump it up quite a lot for it to become smooth. That's annoying. Okay. Okay. 31.6. 30? 30 is not enough. 30.5. 30.5 is enough. I'm gonna wanna do the absolute minimum I can get away with. 30.1. That is good. There's something funky going on here. Let's put in some support geometry here to hopefully deal with this situation. Actually, first of all, is this planar, this thing? Yeah, and it does, at least by eye, it looks kind of planar, so that's good. Maybe we can take this entire thing and just zero out the rotation for now, so we can work in world coordinates, essentially. So... right, there's no cut there. Just join those two together like that, and then what is going on with this guy? Does indeed seem to be planar, but it's something is causing it to get a bit of wonky lighting going here. We can see like a very thin triangle there, so that's not nice. So what if we actually just move this to there, hook those together. Right, the reason for all of this madness is of course that guy, so we need to mark that as sharp. There we go, now we get rid of that. That's funky lighting, and I think I want those to be sharp as well. What if I just bring those up a little bit? Yeah, there's not actually enough vertices there to keep that sort of smooth. That's a bit annoying. Well, that at least looks somewhat decent, I would say. Let's bring that in as well. And that's probably a pretty okay sort of fixture for that actuator, right? We want to make it a little bit more, or shall I say, make it a bit less symmetric. Just for funsies. Is that nicer? I don't know. We can even just bring this guy all the way to here. Is that nicer? I don't know that either. We'll see. Let's not spend too much time on this seemingly unimportant small little details. We need a similarly, we need another. Oh, that's minus 32 is like the max tilt for this thing, specified in the gameplay code currently. If you go past that, this thing starts to intersect with the vehicle mesh there. So it's purely just a visual thing, but still I don't want to necessarily have that happen. So how wide is this compared to the pit? Yeah. What's the actual name of this? Gripper truck main, is that okay? Yeah, this entire file was kind of like started as just a test for you know, how would we make such a thing, and then it kind of just bloomed into a full file. So some of it is a bit messy, but I'll try to make do. 1 second here. All right. So let's take this concept here that we had with this fixture and maybe bring it down to there. Let's see if we can just basically copy paste it wholesale, because it would kind of make sense that those pieces would be sort of similar, right? So if we duplicate that and we move it just down, essentially, just down, but let's move it down in world space and over there. And then we do take this guy. Is this mirrored? It's also mirrored. Okay. And this guy is now also mirrored. So let's actually, oh, not that. Take this and we separate it. Take this guy, get rid of the mirror for now. And that one as well. It can be just flat shaded for a little bit. And then we take this and this, join them together. So now they're in the same object. Let's isolate this so we get a little bit more space to work here. Okay, so now if we can basically get rid of that. Right, and then right now I did something a little stupid because I rotated that thing. Would be nice to have that unrotated so we don't have to guess. Yeah, let's do that. I'm gonna go back to this, get rid of the rotation for a bit, isolate it. And then again, copy all of that, duplicate, separate. So now we can set back the, what was it, -32. We have this thing unrotated. So now this should be flat, so we have a easier time sort of fitting it to the main mesh. Like so. That looks good. Let's actually, just before I merge these two guys, get rid of all the modifiers here again. I've had some instances in the past where I merged some objects and then I've sort of inherited some modifiers that I really don't want, so that can be kind of annoying. But now we can go like so. We can rotate it just around X 180 and move Y and then move it down. So maybe snap that to there. Yeah, that's not good. We need to snap it only along the Y and then only along the Z. That's better. That would be better. And now if we mirror it, we get that same sort of width here between them, which I think is looking actually a little tight, if I'm being honest. But let's see about that when we get that far. Righty-o. Let's not subdivide that, but let's subdivide this a couple of times just so we get some vertices here to actually join with, like so. Should be able to basically do that, and now we have the thing sort of integrated into the mesh. Question is that now too sort of high up? I don't know. So smooth my angle 40, that should be completely fine. We get our nice smoothing there. All right. So now if we take this and we look at the bed, yeah, here's one end and there's another end. So the actuator would sort of go between these 2 points. And then we raise it up to something like that. It needs to become considerably longer. Yeah, that can be an interesting thing to solve. But we'll see. We'll see. I'm sure it makes. I'm sure we'll find it. I'm sure we'll figure it out. That's what I'm trying to say here. Okay. So do we need more space here in the sideways dimension? I think we might. I think we might do that. So we'll take basically that one, that one, that one. Oh, actually, that one, and then we need to do the same for these, like so. Now we can take these edges and just make it a bit wider. Yeah, that looks better. So we can actually fit something there. Okay. This is kind of annoyingly in the wrong place though. Let's move it about there. That looks better. Okay. Coffee sip. My 1 coffee cup per day. All right. So now then. Oh, and this actually needs to be, yeah, this needs to be further back. So we need to sort of probably integrate it into this a little bit. Let's still get rid of those faces there. Yeah, this was a little bit of a hasty thing that I did here. So let's bring it back and bring it like all the way over there maybe. Probably even further. Because that's actually too much probably. Something like that. Because like the previous debug drawing that we did there in the game actually had the thing appear somewhere here. So consider sort of a straight line somewhere there needs to be further back. I think that's probably pretty good. So if we can integrate this into the design somehow nicely. Make a face there. Using the user interface here as a ruler. Which is probably not the most professional way of doing this, but hey, it works, so. So don't at me, bro. Alright. Whoop. That's the wrong edge. That would be the wrong edge. Then we need to do something here. Additional point, probably snap it to that one, but then bring it to the center like so. Put a face there. Something like that. Is that okay? I'm not sure I like this a lot, but might have to do. It's a pretty minor detail after all. And maybe we'll want to now bring this top of this a little bit down. So that and all of the cylinder, just bring it down. Yeah, I think this is probably going to be quite nice. So what we could do now is export these meshes. So export as a basis mesh, blah 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 blah, Reaper truck main, and then we do the same for the bed, and the bed needs to be exported from the origin with no rotation. So bed, and then undo, undo, undo. There we go. So now if we run the game again, and we have this debug drawing going on here. What we are going to see is that those lines don't match up with where we where we actually created that stuff. Okay, so it's jumping around a bit. So this is not super far from where we actually wanted it, but it's a little. And yeah, this one should be a little bit further back. Yeah, that's probably a good idea. Like, let's try to make this actuator arm actually as short as possible. And the further up we tilt this bed, the longer it's gonna be, right? So it's gonna be the shortest when it is around here, and then the longest when it's up here. So here, if we bring this a little bit further down, further back along the bottom of the bed here, we're gonna make the longest length a bit shorter. If that makes sense. And once we've done that, we can go about fixing those coordinates there to actually have the game sort of know where the positions are supposed to be. That's not what I want to do though. Let's do that, and then we do that, and yeah, now we can bring it downwards a little bit. Hey Dimitar, welcome back. Glad to see some folks in the stream, even though this is a kind of an early stream. I wasn't really suspecting, I wasn't really expecting, that's what I'm trying to say. I wasn't really expecting a lot of people this time around. Hey, what's that? What is that? Who are you? Oh, that's a shadow blocker, isn't it? That right there is a shadow blocker. Is that actually visible in the game? I don't know. I think if we hide all of that, we see that there is a shadow blocker, like an extra few polygons in there to deal with the fact that if you have the sun sort of glancing this from the side, some of these corners with like a low shadow cascade might sort of cause some artifacts. So I just added some of those there in an effort to fix that. Let's actually zero that out for the time being. That's weird. Why is that sort of slanted like that? It's annoying. Yeah. Something like that, right? And then what I will do is basically just move this up a little bit. Whoop. Like so. I don't think I've ever seen that in game actually, but you know, whatever. Let's fix it anyway. Okay, something like that. Looks good. Of course, if we want to, we could move this all the way to this point. That would give it a sort of a common line here. Is that nice? Is that neat? I don't know. I don't know, you tell me. Yeah, it's intersecting here with the geometry, but like frankly I don't exactly care. Now we have the collision volumes. Okay, so it's actually not. Oh, that's nice. It's not actually intersecting, so this would even work physically. I was sort of preparing that it would do that, but it evidently does not. Yeah, we can maybe leave this as it is, like right here. We just need to move these guys over to get a little bit more of a straight topography here. Why not? And then here Yeah, this line actually doesn't line up with that. So the question is, should it? Maybe not. Maybe not. Just join those and we can get rid of that. Which of course will get triangulated there again, but you know, it is what it is. I think I wanna break the illusion here that those are actually on the same line a little bit by moving almost all of this like this and that. Yeah, that looks good. And then just move them forward a little bit, something like that. A little bit more. There we go. That's good. All right. Maybe we've messed around enough with this. Here's one thing that I need to do, though. This just makes so much sense. Triangulate like that or something. I don't know. I don't know. I just modeled an axe. It's time for UVs. Hey! UVs, everyone's favorite thing in the world. Those are kind of unnecessary, I guess. Those as well. Yeah, I don't quite hate UV mapping as much as I used to. Now that I have Zen UV and I have UV Packmaster, both excellent additions to Blender's UV mapping tools. And I hear that Blender is actually not that bad compared to some other software packages out there, so maybe I shouldn't complain. Even if I didn't have that. Alright, so that would be the bed. And, oh. What? Creepy truck bed, and the settings look good. Oh, now it works. There's no meshes. I did something stupid. I probably didn't have it selected when I exported it. But anyway, let's move it back. And we can even do the minus 32 again there. So that looks good. Okay. Let's go into the game. I'm going to fiddle and tweak these coordinates a little bit, right? This is where I wish I had a system that would allow me to like somehow mark up positions and locations in a mesh and then extract them from there. Of course you can do that like just by adding like a vertex somewhere and then reading it out of there, but that's a little finicky. So first of all, this bottom one needs to be higher up and just ever so slightly backwards or further back. So these positions are set up in the blueprint like so many other things. Coffee sip. Coffee sip and hit the microphone just like any other professional streamer. So you have actuator vehicle fixture position and actuator bed fixture position. So vehicle fixture position, this is in the vehicle space. We can move it very slightly back and very slightly up, a little less slightly up, like that. Unfortunately, those don't hot update. That would be really nice if they did, but they don't. And this one is in bed coordinate space, so down goes this way currently. So we can move it almost just a little bit down, minus 0.2 maybe, and just very slightly back, so 3.95 or something. Let's try with that. Yeah, would be really nice if the blueprints hot updated like most other things in the engine, but they don't. They don't. Alright, so we went a bit too far with those tweaks. Yep. Oh, come on, why do I have to jump all the way over there? So, a bit back up. Let's do 0.15. And a bit further forward, so like something like that, right? And what about this thing? It's actually looking almost correct. Almost correct. But not quite. So let's move it a little bit forward. Something like that. Just randomly trying. Well, not randomly, but sort of closing in on the coordinates here. Yeah, I think the height might be almost good enough now. Just a bit more forward. And here height is actually perfect, also a bit more forward. So the bed is like that, and that, and what about the height there? Yeah. Something like that. I think we're closing in on it, and it will be good enough. It's like the more sort of the closer to the place you get, the more of these like, oh, it's almost there but not correctly things you get out of it, right? So what we're gonna do now, just for, you know, make our lives a bit easier, is this: zero that out. Actually, no. I'm gonna make a tweak first, I think. No, I'm gonna do something here. Let's move the let's move the cursor to selected right there, and then we'll add a mesh here, cube. We'll call that cube bed position, and then we'll just actually we'll hide it. I think we'll hide it completely, and then we'll do 0 and 0, because meshes do auto update, hot update in the game. So I'm just gonna correct it the other way, because there's, you know, nothing is telling us that this is the correct place. It could be the other way around. So go that way instead. little bit backwards, and export bed, and a little bit upwards, right? And we don't actually want those guys to follow along. A bit more upwards. Yeah. Yeah, I think that is probably good enough. So now if we... Oh. we lower it, but with the correct controls, you can see that it basically just stays there on that. That's good enough. That's done. So then we do a quick cleanup pass on this. Kind of my OCD prevents me from submitting these things that are almost straight, but not quite straight. Right. And it also kind of make UV unwrapping a bit more annoying when you don't have quads, true quads. Okay, so that's that part. And now we can take basically the bed position. Oh, we don't actually need it anymore, do we? Because we can actually just delete that. We still have the cursor there. So then I can just go selection to cursor and it snaps back. And then we can reapply our rotation. Okay, that would be that. And then this guy. What were the tweaks that we needed to do for this guy? So it needs to be a little bit back and a little down. So a little down. And I think that is what we want to do with moving it back, like so. And that is truck main. Yeah. That's gotta be pretty close to perfect. Right there. That's absolutely perfect. Okay, cool. Cool. You can see the actuator there inside of it. Okay, yep, that works. So, what's the next step? That would be actually modeling the actuator. And we can do something pretty simple here to not put a whole lot of time on it. I mean, we could go super fancy. But I don't think I want to do that with a system like this. So, what I've been doing for things like this in the past is have two different parts, because it needs to be like it needs to get longer and shorter, and basically we will be modeling. Let's take this guy, probably like maybe just this top, and then the cylinder. Duplicate it, separate it. We have this. Come on, there we go. Like so, and then we can even apply this mirror here. like that. And this is just a just to get the size correct. So if we move the cursor to here, and then we move the object origin to cursor, and then finally we move the whole object to the center, world origin. This is sort of how, this is what the fixture looks like on both sides, the part that this thing is going to connect to. So let's call this like fixture test, or whatever. I'm gonna throw it away in a second. Now we're gonna create a new mesh. It's gonna be a cylinder, and we're gonna rotate it around Y 90, and we're gonna add some radius to it and take some depth away. Just a bit more, something like that maybe. And then we're gonna add some vertices to it, because this is clearly not enough. So let's do 16 maybe. 16 is gonna be fine, I think. I wonder if the radius is too large actually. Is that better? I think that's probably better. Cool, and then auto smooth. And then we have forward, so that would be that way. We want it to basically sit at the position where it's fast, and then look at the other position, at the other end of the actuator. So we're going to do another cylinder. Let's rotate this around X 90. We can use just as many vertices, I think, for this. I'm going to put the radius down to like 0.6. And then depth to something pretty... Let's think about this for a second. Is this going to be the upper or the lower end of this? I think this is maybe going to be the lower end, which is typically the thicker end. So just move this out a bit, extend and scale. Actually scale some more and extend. And now I don't know, I don't exactly know the length that we need to go for here. Something like this, and then a bit forward still, so Y. And then we essentially want like a hole here where the thing is gonna sort of enter this. But I think we're gonna actually leave a face here. And kind of pretend like that face isn't there. But we're still gonna have it. Let's move that over to the side a little bit, auto smooth still. And we can mark some of these as sharp just in case we mess up the... what? Didn't I mark them as sharp? Mark sharp, there we go. Something like this. But it is for sure gonna have to be longer than this, so let's move it over. I think something like that maybe. Right. And then if we do, this is like actuator. Let's call that actuator 0. And then we add another one. We can move it over to X1 maybe. That's a bit far. Let's do 0.5. This thing is going to be the other end of it, and it will basically be the same but without the thicker part. Something like this, right? And then we take basically this guy and we rotate it around Z180, and then it will sort of be connected to this. Right, and then go move this way. This connection looks bad though. I think we need to do something about that. But what? I think I'm gonna inset. No, not inset actually. That's a bad idea. But we're gonna do a loop cut and slide, and then move this over to there, so that we get a bit of a hard edge there. And then for sure we're gonna need to make it a bit more pronounced. And I think this guy should be a little thinner. How about that? Maybe even a bit more. Scale, not Y. Whoop. I think these ends are a little too large still. So let's do scale, not X, 0.8. Oh no, that's not what I want to do. What? How's that Z? Scale Z. This thing, oh, it's rotated. Of course, it's rotated. Okay. Okay, so scale not Z is what I want. Yeah, exactly. Scale not Z, 0.8. And yeah, I'm gonna fix that in a second. That looks better. It's ridiculously large, this thing. Scale. Yeah, that's the same thing. 0.8. Good. Good. And then we hide that for a bit. Move those inside of that. Like so. Oh, actually we can just, yeah, we don't have to do anything that complicated. We can just move this entire thing there. Much easier. Okay. So we might not need these faces here, nor these faces here, but I think I'm gonna keep them there anyway. So if we add back fixture test, yeah, you can actually see a little bit of the face there. So yeah, let's keep them around. That's good. That's good. Okay. So I think this connection here is probably good enough for now, at least. Do we want to do something a little more interesting with this, such as like moving that away? That looks kind of interesting. Oh. We can even do this maybe. Just move that. Is that even more interesting? I don't know. That doesn't look bad, at least, so maybe we'll keep it like that. Okay, so now then, we reset all of that, set that back to yeah, we wanna reset that so that they both point in the forward direction. We still have a rotation here, so we need to apply that. Apply rotation. And that should have nothing. And that one is just a test, which we can get rid of right now. Like so. So, right, now the question is, if are these things sort of long enough? Kind of thinking probably not. But I think we'll code up a little bit of 3D math to make them face each other. Next, and that should allow us to figure out how long they need to be, essentially. And I think I'll do that after getting a little bit of water. So back in a few seconds. Alright, we are back. And Debitor is done UV texturing. That was fast. Or did you just do the UV unwrapping maybe? I just misunderstood you. Coolio. Right, so what we need to do now is export these guys. So we have actuator 0 and actuator 0.001. So that's bad. Let's call it actuator 1 instead. And these things need to be exported like this, sort of on top of each other. So gripper truck. What? Actuator 0. Export, and then actuator 1 plus export UV only. Now with texturing phase. Okay, that's nice. That's nice. Right, so how do we do this now? We can get these things into and or onto the vehicle in a number of different ways. Like the easiest one would be to just quite simply add a mesh component like this basis mesh component here. Just give it the bin mesh path, which we should already have gotten. Yeah, we have actuator 0 bin mesh and actuator 1 bin mesh. Whoops. That's like the easiest way. Then you need to give it a material and you need to specify whether it's dynamic and blah blah blah. That's one way of doing it. It's the easiest way. And that is essentially what we do with the bed and the hatches. So we have something like bed mesh component, and then we need to give it the name of the component that contains the bed mesh. And then the same for the left hatch mesh, right hatch mesh. So we would just have like actuator 0 mesh and actuator 1 mesh here. That may be completely fine. I'm wondering about the positioning of that though. Like if we take the bed for example here, let's see where's the bed updating. It's here actually. And it's not just the bed, it's all of them. Since we don't actually attach any of the meshes to the articulation graph, we need to set the same rotation manually on the meshes C nodes as well. Another way would be to detach the meshes and attach them to the articulation graph. Yeah. So this comment here is just me going like, I don't want to mess with the basis mesh components data. Which we can do. But that's kind of something that the mesh component doesn't expect us to do, so maybe try to avoid that. What we can do instead is calculate the position and orientation of those C nodes every frame in this component, and then just set them on the thing. Actually, we don't even need to do that unless. Yeah. Okay. So all right. Yeah. So if here's one. I don't have my drawing tablet here. Let's get the tablet. Do like another color. Broop. Nice pink. We have this position in the local space of the vehicle. We have this position in the local space of the bed. And as long as we have the mesh attached to, let's say, the vehicle, we need to calculate this position in the vehicle space, which actually doesn't change, only the rotation changes, and then this position in vehicle space. So this would be only rotation, and this would be position and rotation that changes, and they only change whenever we move this thing up or down. If we don't move them up or down, then they're just going to be, since they are attached to the vehicle, they're just going to be moving around normally, and that's great. Still going to calculate their world matrix as part of the rendering, but we don't have to do any of that stuff. So I think that probably makes sense. So attach those both to the vehicle. Yeah. That makes sense. Let's try to do that. Let's see if I've forgotten something important here, but let's hope not. So, add the components. That's the easy part. So mesh component. This would be actuator 0. The mesh path is this guy here, actuator 0. And then we have to give it some material. One of the blockout ones. Maybe we can give it I don't know, dark gray. And then we give the other one just a normal gray. So actuate the vehicle fixture position is exactly what we want here. We want the mesh position to be there. Mesh rotation we don't exactly know yet. It is a dynamic mesh. Doesn't block the nav mesh. It's actually something I need to... Yeah, windshield doesn't block. None of these should really block the nav mesh. Right hatch mesh does, so that's a bug, that's a bug. Bed mesh doesn't. Yeah, okay. It's a good thing to check. Right. I think that's it basically. And then we want another one, mesh as well, which would be actuator 1. And that's just 1 gray. No nav mesh blocking. And we need to give it some position. We can't really use this position here because that's the position in the space of the bed, and we actually need to give this in the space of the vehicle. Right. But okay, I will do this. I will just move this one forward, and we'll actually add a note here. Come on, note, add a note. So the position of actuator 0 cannot be determined here, but gets set at runtime. It still needs to be non-zero to give it its own scene node, right? Like this, you can move that up. So if this is just 0, 0, 0, like that, then the system is like, oh, okay, it's not set anywhere. We can just add it directly to the scene node of the car. We don't actually want that. We want it to have its own scene node, which is then nested underneath and can move sort of freely within the local space of the vehicle. That's kind of just like something you need to know that the engine does. So something like that. I think that should get us started. Now if we look at the vehicle here, we should even see those actuators. So here's one. Look at that. Looking fine. Actually, might even be somewhat correctly sized. Might have to get a little longer. We'll see. And then the other one is here at the at the bottom. We can move that up a little bit, just that it's not there. Let's move it to maybe like 1, and it should move somewhere closer to this. Yeah, it's actually kind of close to where it's supposed to be. Actually kind of close to where it's supposed to be. Right, so let's just leave it at that for now. And I think that's it. I think that's all we need to do here on the data side. So let's go back to the code, and here we need a function to actually calculate this. So let's do function calculate actuator transforms. And this needs to be done whenever we set the steering values, and it should also be done on the client, by the way. So if self context on client, and it should also be done when the whole object has been created. Apply steering values is called but that doesn't mean anything here in this case, no. Except this might not be the the best place for this. Let's copy that. Undo this. Actually, I think it might be best to have it here in apply steering values. Here. So when the steering values are updated, this thing is called. It's also called from onObjectCreated. Yeah. Yeah, so this will actually work out. Because when the steering values get updated, we call it here. And then we update the graph. And then we need to call it to calculate the actuator transforms. That is good. That is exactly what we want. Okay. Oh, I actually forgot one thing that we need to add to the data. So we need actuator we're not actually calling them actuator 0 and 1 here. That's a little annoying, isn't it? Let's do it like this. Let's call it actuator 0. I'll call it actuator 0. Oh, not 9, but 0. And vehicle in parentheses. And then actuator 1 in parentheses bed. And this would be actuator 0. Actuator 1. If we go look at the data, which is here on the left, we need to actually fix up this so that it matches the new schema, or whatever you want to call this, on the right. So this would be actuator 1. Actuator 0, actuator 1. Like that. Right. And then we have actuator 0 mesh component name. There's the new thing that we need to add. So actuator 0 so. And then we just replace this with 1, and that could be bed. And they're strings. Good. And finally we need to actually change it here as well. So it's actuator 0 and 1. Like so. And here as well. 0 and 1. And even here in this, we have actuator 0. And we have actuator 1. So let's make sure this builds and works the way we expect it to for doing anything else. So we go to the asset browser now. We should be able to hook up that data. So in other words, set those names. Actuator 1, maybe we can call that mesh, and actuator 0 mesh. And then that would be that, and that would be that. Save. Fixture. Oh, it's supposed to be fixture position. Where did I put it? Oh, Is it actually? Oh, it can't fit. Is that the problem? Yeah, I think it's too long. It can't fit there. Let's remove that period. Yeah, there we go. All right, so vehicle and bed. Yeah, that looks good. That looks good. Okay. We can minimize that. And we can minimize that. So now let's play. All right, unknown field. Okay. So there's something funky here. Let's see. What is funky? Actuator 0, actuator... Oh, right. Okay. Yeah. Yeah, we have those. We have the data. It says unknown field because it doesn't know what to do with those strings. And so what did we give the names to? Here was actually the 0 mesh component name. Basically just need to specify that yes, we do expect there to be 2 strings there. And while we're at it, we can of course actually store those in strings here, just like we do with the other mesh component names. So we need to initialize the string here because we are in Zig, and we need to tell it which allocator to use. All right, and then also deinitialize those. Like so. So now we should be able to load it. Yeah, so the JSON parser in the Zig standard library doesn't like when there are fields. You're trying to parse an object into, or data into an object, and there are fields that it doesn't recognize. I think there's a way that you can sort of make it calm down, but you kind of don't want that, at least not in this case. You kind of want, because it means you have messed up somewhere, so you just want it to complain to you. Right, so if we look at this, the length of this thing here, we can sort of see that yeah, these 2 guys are not gonna be enough to cover the whole distance, but we'll make them longer. That's not a problem. That is not a problem. Okay, so now we need to pose arguably the most tricky part. Now we need to pose them so that they're sitting at their respective places there and face the other one. So how do we do that? How do we do that? Well, first of all, let's get some mesh datas for them. So actuator, it's a difficult word to write for some reason, I don't know exactly why. So mesh component data. So the mesh component, the standard mesh component, is actually a C++ component, not a Zig component. And that means that we can't just get a pointer to what did I do? I was supposed to be mesh data, like that. Yeah, we can't just get a pointer to it from Zig and go like, hey, call things on you, please. Because Zig doesn't know what to do with C++ pointers. So instead, I have this mesh data object that you can get from a mesh component in Zig, and it gives you essentially like the things that you, oh, that's not the right one, the mesh component name. It gives you the things that you are most likely going to be interested in. Essentially, the scene node, which lets you move the thing around, the mesh, which lets you get information about the actual geometry and things like that, and then the mesh instance, which lets you like hide it and do things like that. Those are the most likely things that you're going to want to do with that mesh anyway. And so we are getting get and assert mesh component data. So we better have those components that we set up there in the data. Let's make sure they're correct. So actuator 0 mesh, that's that one, and actuator 1 mesh, that's that one. That's good. Okay. And they are going to be, let's see, they're going to be nested under the vehicle itself. You can set a parent component here if you want it to be nested under like another component, which we actually do for the hatches. They're nested underneath the bed. But here we don't set any parent component, and that means that they're simply nested under the object itself. So in the space of the vehicle. And then we have here BP props. Actually, I can take that. We do it in a few places here. It's basically this one. Assert that we have BP props, and then use that to do things. So BP props has actuator 0 fixture position, right? Act 0 pos. This is already in vehicle space. And then we have actuator 1 position, which is not. It is in the bed's space. Right. So we need a matrix here to convert it from bed space to vehicle space, and we can get that from AG, stands for articulation graph, and we I will get back to this when we start looking at the gripper arm, once we have the actuator done. But here, quite simply, we have nodes, scene nodes, truck bed graph, bed index, get, let's see, local to parent transform. That is the one we want. Yep. So bed to vehicle matrix. Let's call it like that. Const act 0 pos is bed to vehicle matrix transform point pp props act 1 fixture position. Right, so we need the 2 positions in vehicle space as the meshes scene nodes are attached to the render scene node. The render scene node is a scene node that is essentially moved around with the object on the client in such a fashion that it gets interpolated and looks smooth. Rightio. So now we should be able to basically just call that. So we have actuator mesh 0 data, scene node, look at scene node, Oh. Oh. What does look at scene node do? We could perhaps use that, but I think look at scene node probably assumes that we're gonna want to use the world up direction as the up direction, and I don't want to use that in this case. Let's see, what does this do? Look at. Just look at. Yeah, in world. Huh. Yeah. If space is world, then we use unit y. Actually, we use unit y in both cases. That won't actually work. We'll have to do something better. Which is a little annoying. But if we have matrix 4×3, this should have a look at, yes. And this look at allows us to give the up direction. There's the third parameter. So that will work. Yeah. So basically, orientation for the zeroth actuator 0 would be like matrix 4×3. Can set this to undefined because we're gonna write it here. Actually, what does this? Does this modify the? Let's see. Look to. Yeah, look to annoyingly sets those to 0. I don't exactly know why it's made that way, but let's not change it right now. But okay, that means that we can just set this to undefined for now. Undefined. And then we do orientation 0. Look at, and let's do look at safe. Which just basically protects you from the case where up direction and look at pos or look at direction overlap. But that shouldn't be possible. I don't know, let's use look at safe anyway. So I position would be act 0 position, look at position would be act 1 position, and up direction would be up, but it's not world up. So we're still gonna give it vector 3 unit y here. But this is gonna work because we're gonna set this matrix explicitly in the parent space, not world space, like look at scene node did. So that should be good. And then we need to do actually we can do this. This can be called transform 0 because we can just do everything with this. So we can do set translation, and this would be act 0 position. So we need to set it after we call look at safe, because look at safe wrote zeros into that one thing. So that's not good. Right. And now with this we should be able to do self dot actuator 0 mesh data scene node set oh damn, we can't set it. We can't set a matrix on this. We need to set a position and an orientation. That's annoying. Okay, set orientation quaternion from rotation matrix init from rotation matrix transform 0. So this is actually going to be an orientation after all. It's not a transform. Can get rid of that. Bye bye. We actually need to call in space, and we give space dot parent false. Self actuator mesh data scene node set position in space, and position is that act 0 position. Parent and immediate update also false. So I think that should make the thicker part now face the other part. Let's see if that is the case. There's a reasonably high. Whoop! Could not find mesh data component. What? What? Was it an empty string? That's not good. Actuator 0 mesh. Actuator 1 mesh. Actuator 0 mesh component name. Right, it's because we're not setting it here. Okay. Okay. So we need to do try self actuator 0 mesh component name set props. And the same thing. And then the ones are the same. If any of this is unclear why I'm doing something, then just feel free to ask. And feel free to challenge my understanding of how this should be done. Set orientation, unhandled reception, read access violation. That's not good. That's not good. What are we doing? Let's see if we can actually debug this thing. Init from rotation matrix, okay. What is this guy? That looks like a valid matrix, I think. Yeah, I don't think that's should be a problem, but let's do quad 0. Just assign this here. Maybe. That's probably not the issue, but let's make sure. Yeah, it is not the issue. Right, what is the oh, there's 0. Yeah, that's not good. Why is it 0? Oh, hey. No, I think that should have worked out. We are on the client, right? Yes, on the client. Let's restart this. So are we not actually getting any? Oh, I know what the problem is. The problem is the fact that we have these components after this truck bed component. What I don't know is why this assert here doesn't actually blow up. That's interesting. Let's see if we can actually figure this out. So data. Yeah, it can't find anything. Does that function actually not work the way I expect it to? I guess it's a pretty good find if it actually doesn't work. So mesh CPP pointer tries to get the CPP pointers for all of those. Return null. Okay. What? That's weird. Let's look at that one more time. Go in there. Yep. Right, so we go here. Interrupt name. Actuator mesh. And then some crap. And then this thing returns null. No, it doesn't. Okay, we need to actually probably go and have a look here what this thing does. All of those are actually null, so that makes sense. There really kind of shouldn't be a component with that name yet, because we haven't gotten to it. If that makes sense. But I kind of want to dig into the C++ side here and see what we do. Mesh component. What is your name? Full name. I have to look at it here probably. So now we're on the game engine side. This is C++. We can look at full name. Actuator 0 mesh. Okay. Ah. Yeah, this is kind of subtle. I think I know what's happening. We are in onObjectCreated. So this has to do with like the sort of staggered creation of these components. First, create is called when a component is created. And then once all components are created, onObjectCreated is called. In this case, the component actually exists because all of the components have been created, even though it's sort of sitting after this component in the list. But its own onObjectCreated hasn't been called yet, and that is what actually creates the mesh. So I think really what we should do here is this. First of all, we should find this. Could not find mesh component data blah blah blah. But if data dot let's say mesh instance maybe. CPP pointer, or actually we can just do is null. Basically what I want to do here is this. I want to assert that does not happen. So not is null. So mesh component data hasn't created mesh component something hasn't created its mesh instance yet. Let's add a comment here that the mesh component might be created but not fully initialized at this point. Assert that it is. Something like that, right? Because you want to, if you call this get and assert, you want to basically know that what I'm getting from the engine is solid stuff. And the fix for this is, of course, just to rearrange the data. But now we should blow that assert there. Yep. There we go. I don't know why the focus was somewhere else, but we should get it. Yeah, boom. Mesh component actuator 0 mesh hasn't created mesh instance yet. That's a bad. Rather than a crash, it's a bad. So let's move it up, just above that. We should move that up as well and that up as well, so that the truck bed component comes after those meshes. Now it should work. There we go. A bit of a silly little thing, but still. So what about if we now raise this? Look at that. Look at our beautiful actuator doing its thing. Blah, 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 blah. Yeah, we need to make that longer for sure. I think other than that, it looks pretty good. It kind of looks to be properly connected where we expect it to be. So all of that is good. Yep. All right, so now the rest should be easy. We just do the same thing for the other one. So essentially, this wasn't a problem after all. We can just yoink it back there. Let's do something like this, actually. Like that, and then we do the same thing for the other one. So here we want to sit at actuator position 1, and look at actuator position 0. Yeah, we could essentially just flip that, but I don't think it's really... This is not super heavy. Look 2 is actually the thing that does it. Yeah, there's some cross products and whatnot, but blah. Who cares? It's probably fine. And then, oh, then we do 1, 1, 1. And that should be it, I think. And you know what, actually? Since we don't need any immediate updates or anything like that, this thing is exactly the same as just using the shorter form. Set orientation and set position, and then we take those guys away. And those guys away. So by default, the scene graph kind of expects you to move those things around in the parent space. So if you just go set position, it's the same as going set position in space and then specifying parent space. Okay. Look at that. Beautiful. So it looks kind of nice so far, and then it doesn't work anymore. But okay, that should be an easy fix. We just make those a bit longer in Blender. Oh, wrong object selected. Take those, move them like that maybe, and we can just, this is super nice now because we can just export here and bloop, there we go, already visible. Oh, that's not what we want. And that's number 1. Alright, how about that? Let's take those debug spheres away. They're not really needed anymore, and we are in the wrong solution. There we go. update. There we go. Draw actuator line. Hello, Aku. Good morning to you. Good morning to you from your weird time anomaly in Tampere. Yeah. Isn't that cool? Isn't that cool? The answer is that it's pretty cool. Up, 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 up. You know what that means? If you followed me for long enough, you know what that means. That means that I have a dynamic flag set incorrectly. Let's see, actuator mesh needs to be dynamic. Bloop, there we go. Now it will work. Personal Heidi says, hi, how are you doing today? I'm doing pretty well. Thank you for asking. Been streaming almost every day for past few days and getting a lot of work done. All right, so now it shouldn't disappear anymore. Oh, nice. Have to move the free camera. Brip, brip, brip. Yep. Always with the dynamic flag. I've been meaning to add actually a warning to the engine, where like if you add a mesh that's marked as not being dynamic to an object which has a dynamic body transform, then it will give you a warning, but I haven't done that yet. There was some slight complication with that. By the way, man, please add me as an Easter egg. What? You mean like an Easter egg to the game? Let's see. How does this look? Look at this. This almost looks like it could be actually like physically here. It looks neat. And it also doesn't protrude from the end of this, like some of my actuators have done, or like suspension springs and things like that. I think this actually kind of turned out neatly. You can even see it here if you're driving. Depending on how we do with light probes and things like that, it might just be too dark to see actually there, but we'll see. Right, where's the spawn point? I think it's about here, isn't it? Yeah, oh, a bit forward. Yeah, it spawns like, I think I set it to 70 of those, and then it stops. And then you can go. I did nice sounds. Yeah. Cool. This is fun. You know what will be even more fun? When we get the gripper arm in the front, and then the thing can actually like throw, like pick up boxes and throw them in the back, and then you can go and dump them somewhere. It's gonna be even more fun. Okay, this is nice. My icon is ugly sandwich. Please make it real. I don't know. There may or may not be some community Easter eggs or inside jokes already in pre-alpha 1, actually there is a community thing in pre-alpha 1. So I'm not against doing that, but I don't know. Ugly sandwich. It could happen, but I mean, you have to kind of earn it somehow. Or you have to make a mod for the game and add yourself. It also highly depends on my mood when someone goes like, "Hey, make that an Easter egg." It also highly depends on my mood. If I'm if I'm not feeling particularly productive that day, I might just go, "Yeah, sure, let's add it right now." But on a day like today, which I sort of wished we had more of, where I actually just get things done. Yeah, I don't think there's not going to be any Easter eggs added today, I think. Alright, hey, this was nice. What we're gonna do now is have a 10-minute break. And when I come back, we're gonna start looking at the gripper arm and adding it to the front. So that would mean basically this thing here, which looks a little strange here. I want to make some changes to this thing, but it's basically this thing. And thanks to some neat code that I wrote yesterday, it should be a lot simpler to add like this sort of what do you call it? Articulated feature to the vehicle now. So that should be really nice. So basically, if the bed is down like that, this now only has one side of the fingers, and this is actually using the design from the gripper. I think I want to redesign it a little bit, but that comes later. It can sort of grab something here in the front and then just sort of throw it like this and release it. And that should be nice. So I'm gonna start working on that in like 10 minutes or so. Do you have a Trello board of remaining work that needs to be done before release? I have some Trello boards. I do use Trello, but I don't really use Trello for this project, to be honest. I don't find it. I find that it's not really working for this project. I've tried many different project management tools over the years, like Monday and Asana and even Jira, which we use at work. And so what I use instead is actually is Checklist, and yeah, you can see pre-alpha 2 to do. I have a whole bunch of things here. These are mainly things that I've come up with myself. We also have the pre-alpha, let's see, master rest of demo to-do lists. This was essentially the checklist for pre-alpha 1. I've actually removed most of the done things, but a lot of the stuff here is actually things that just I marked as, hey, we want this for pre-alpha 1, and then just didn't get made. And then we have feedback from pre-alpha 1, so we have positive, and then we have critical and constructive feedback, and there's a lot of stuff here. So yeah, no, it's not a public list, no. I mean, it's public in the sense that I'm showing it to you right now, but no, I don't have a public. I don't really believe that that's a good idea. I know many people do it, and maybe it works for them. I don't believe that that would be a good and nice thing for me. You guys would just get annoyed with me when I don't do things in a particular order or something like that. But yeah, we'll see. We'll see. I also kind of change how I work occasionally. Some things I go like, right now, well, let's make a Trello board out of this, and then you know, I do part of a larger work using Trello. But checklist is what I just keep coming back to time and time again. I just have like a whole lot of stuff here. NVRHI, for example. Here's like all of my notes for what was to be done, and then I've checked off stuff when I've done it. And here's, for example, the remaining D3 D12 work that we need to. I still need to fix essentially all of that before I can really start targeting that. And then we have some new bugs as well. So I think some of those might actually be fixed. And yeah, checklist is just so super simple to do and use. Mod support interaction point. It's just like a lot of this is actually done already. Now you can just go like establish what a mod should be in terms of files, and then like me just sort of spilling out almost like a brain dump here. And I think essentially all of this is done. I just haven't really used it as a to-do list. Stuff like that. But yeah, it's not a public list. And like I said, I don't think anyone would really be happy with that setup if I were to use a public list. Not me, and not you either. Alright, but hey, this is good. This is really good. I'm liking this a lot. And we will keep liking this in about 10 minutes time. So let's put on a quick break visual, and I'll see you in about 10 minutes. And we're back. Hello everyone. And welcome back from the break. So, the gripper arm is next in line. And actually I realized something, I was on the break, that this gripper arm is like remarkably similar to the bed. So both of them have like this main body thing here, which rotates around the x-axis, like this. And then they have these individual objects that rotate in the opposite direction and around, well, Y in basis, but that would be Z in Blender, like this. And here in the front we only have one of these because I want to redesign this. This looks a bit strange, but it would have another one here, right? The setup is actually very similar. The difference is that this grabs things while this holds things, and so actually grabbing requires us to create like an additional temporary joint between something and this gripper if you want to actually like reliably hold it. So there's going to be a little bit of code difference there, but like overall they're actually very similar. So one thing that I've been meaning to do for a while already, let's see if this is also mirrored. Yeah, so we can just model it here on one side. What? All right, okay, yeah. This also has a mirror. It's just marked as being visible in edit mode. That's why it looks different. Same with this. Anyway, I felt for a while that this looks a little weird to have this sort of round thing here at the end, and I think we want to actually continue it a bit that way for it to look sort of nice and balanced. The visual design here is just kind of strange with it looking like that. So let's start by doing that. Save this Blender file. I don't remember if I saved it earlier. And how should we actually do this? It should probably follow the same sort of idea that we have this sort of depression here in the middle, and then we have this sort of edge that is raised. And I don't exactly know what I want with this, but I just know that I don't want it to be like, I don't want this to be the end of it. I want it to continue slightly further on. So okay, what we could try to do here is this. Let's take a copy of, let's see, what is that? That's just a single face, like so. Same thing here with the back, like that. And then we can basically just do this. We can like quite simply delete that side. Whoop. Bye bye. Faces like so. And then we do duplicate, probably rotate 180, and then snap it back into place. So now we have this sort of thing. Merge by distance should merge those things together again. Together at last. Not sure if we should keep those edges there. Let's remove them for now, at least. I don't think we need them. And now we can of course do whatever we want with this guy. and that's the sort of thing that I haven't necessarily figured out what I want to do with it yet. Let's take that edge, add that as the transform reference. And then let's add that edge. Yep. And scale individual. We actually need to do probably like this, right? 0.04. Thinking if we add an end to it like this, that might look cool. It also might look bad. It's also a possibility. And I think we need to have these as sharp. Same as these. Those are already sharp, but we mark sort of where the round part ends, essentially. Maybe a little more balanced. But is it enough? Should it be even more? Difficult to say. Let's save this and go back and have another stab at it. Oh, I don't have enough undo steps, do I? It's the most annoying thing. Why does Blender default to 32 undo steps? Let's do 256 for sure. Oh boy. Oh boy. How annoying. Yeah, I recently upgraded to Blender 4.4 and evidently I hadn't set that. I always have it set to 256, and that's typically enough. 32 is definitely not enough. Need those as well. I need those as well. Okay. Bye bye. All right. Try this one more time. Oh. Yeah, that's not good. Get rid of those. There we go. So like if we keep this sort of straight for a bit longer, and then we do the sort of the slight narrowing there, would that work better? I'm not sure. just might. Something like that. Is that nicer? Let's do that one as well. Sharp. Because now it kind of looks like it is this straight beam or boom here. And then like at some point they just have added this round piece. In some sense I think that looks nicer. Yeah. We might keep it like this. Okay, so what if we now wanted to export this? And like I said, I'll probably redesign this part here, the front, the actual grabber. But let's start by just quite simply adding this thing here so that we can oh, we have the wrong transform there again. So we can do this sort of movement here. And also one thing I want to test is that if we have this kind of arm here in the front, is this gonna hit every single rock and other obstacle that might, you know, be in the front of the vehicle, so that we need to actually lift up the arm slightly, something like this, when it's in the sort of rest position, right? Or something else, or just like redesign it so that it doesn't do that anymore. That might be an issue that we have to fix somehow. Anyway, let's do a Smart UV project on that one. That's actually something we didn't even do on these guys. Let's do that just to be sure. So that was actuator 0. Yes. And then actuator 1. Smart UV project 1. Yes. And we can hide that as well. And then we do this. And I want to move it to the origin. And I don't think I've ever actually exported this. We need to give it a name. Gripper truck arm, probably. It's already an actuator. What is that? That's weird. Yeah, let's call it gripper truck arm. And we can do means vehicles, gripper truck. What is this actuator without any number? Okay, I think that's something that I just accidentally exported, so let's get rid of it. Okay, and now we can move this guy back. There we go. Actually, what we can do is the same thing as here. Cursor to... All right, cursor to selected. Move it there. Do the UV unwrap. Export it. Arm. And then do selection to cursor. Yeah, that's an easier way to do it than doing the undoing. Okay. Good. Okay, so since the setup for this arm is so similar, I wonder if we should just basically copy paste the component for this bed, because there's going to be a lot of similarities between the two. And then start modifying it. So what should we do? It's like messing with this actuator. It's fun. It's just fun. Right. So we already have probably a gripper arm component. This is a slight monstrosity, 950 lines. And all kinds of crazy things. This is for the gripper, the original gripper, which is not this vehicle, which is not very liked by anyone, including me. Still might have a place in the game, but the gripper truck is kind of replacing it for the things that the gripper has done so far. But this is such a crazy component that I think we'll just want to take a few small things from this, like the grip joint. The grip joint is created between the gripper arm and the gripped object when the system determines that an arm has a good grip on the object. So this part specifically, I think we will want to actually take. And then there's some like message sending here. Whenever we have gripped an object, we send a message about it. And I think also whenever we release an object. Create grip joint, yeah. And that's just a fixed joint. Fixed joint between the object and the gripper hand. So this stuff we're gonna have to take from here. Send message with params. There's supposed to be a okay, evidently not dynamic object gripped. What do we do with that? Do we do anything with it? Might not. Might not actually do anything with it. Okay, we do something with it. Yeah, okay. Yeah, so there's something called a receptacle, which you need to put some of those power cells in and things like that. And if you have gripped an object that is currently input into a receptacle, then the receptacle needs to react to that. Stuff like that. But okay. Let's just start by adding that arm there. So we have truck bed component. What about this guy then? This is also not a simple short component, but it's significantly shorter. 499 lines. So I think we could probably take this guy and modify it. Yeah. It has almost exactly what we want, except we don't want this actuator stuff that we just added. And instead we want that grip joint. But let's take this guy and just copy paste, and we'll call this the gripper truck arm component. Like so. And then we need to register it. And we add it here as well. The gripper track arm component will get gripper track arm component properties. Like so. And just like the bed, we have this kind of graph here. Instead of the bed, we have the arm, which is this thing, which is like a rigid object in itself. And then we have the fingers. So this would be the left fingers, and then the thing that don't exist here are the right fingers. Like so. That is that. And then actuator mesh, those we can take away. We have mesh datas. So mesh component data, that makes perfect sense. And it is the same size of this array here as we actually have elements in this enum. So we have a mesh for the arm, one for the left fingers and one for the right fingers. All of that makes perfect sense. X is probably going to be arm rotation amount. 0 is fully forward and 1 is fully backward. And the fingers open amount. Something like this, right? 0 is probably going to be open and 1 is closed. Fully open and fully closed, right? This would be not truck bed steering values, but gripper truck arm steering values. So by default it is 0 and 0, so fully forward and fully open. It seems like sensible defaults. What else do we have? We have a context avatar tracking component which can read input directly. We have the blueprint properties, physics engine, physics scene, game object, mesh datas. Yes, basically exactly what we need so far. And then we have an articulation graph. And here we need to give it this enum here. And this will now be called something else than truck bed graph. Let's just call this gripper truck arm graph. And it has a helper function or method here. Member function is probably the correct term in Zig. So I don't have to type at int from enum, I can just type .idx. So it's shorter. And graph size, we use this in a few places, so it's just easy. How many of these we have. And then we need to give this to the articulation graph. Hey, these are the objects in the graph that we want to, create an articulated feature out of. And you also give it the type of avatar tracking component, the context there. So that's all good. And then we create, it's steering values, blah, blah, blah. That's actually, we don't need to do that at all. Because it's the initial value. Why do we do that? We don't need to do it here either. That's stupid, isn't it? Unless we actually want the callback to fire. Maybe we do want the callback to fire. I'm not gonna change that. It's probably fine. It's probably fine. Well, we do set the callback after that has been called, so whatever. Let's leave it as it is for now. Look at that later. So then we call actuation, no, not actuation, but articulation graph, AG. Articulation graph create and articulation graph destroy, and then steering values also need to be deinitialized. And then we need to get the mesh datas. So of course here we don't have any bed mesh, right, hatch, blah blah blah. We have the arm stuff instead. So we can probably just replace bed with arm in most of these cases. And hatch we can replace with fingers. and the actuator stuff we can just take away, like so. Arm. Yeah, let's see if we can just replace some of this bed with arm. Replace, 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 replace. All of that. Yes, those are slices. So let's see. This is a slice. This is a writable slice. So arm fixture position. When it comes directly out of JSON, it is a slice of 3 float 32s, or it can be any size, but in this case it is 3. Strings in Zig are typically const slices of U8 like this. So that's a string. It can be a string literal, or it can be just a reference to some other string. So these are slices. Then we have arrays, and this is an array. You don't need to look at that currently. Just look at this part. Right? If we take that away, now it's a slice. But if we give the size here in between these square brackets, this is a fixed size array. And this horrible thing here is a way to initialize every member of this mesh datas array with this, which is like the default. Initialize with default values. We do the same thing here for this articulation graph thingy here. Initialize this with default values, and this syntax here is like initialize with default mesh component default values to as many as needed, and then we essentially give it this double multiplication here can be used to initialize sort of splat over the entire array. It's a really horrible syntax, but still it's kind of neat that you can do it all on one line like that. But yes, empty square brackets and then the type, that is a slice. And empty square brackets followed by const and then a type is a const slice. All right. Let's do fingers and fingers, and I think here we now have to do like this, the big F. Just replace all of those. And so one of the reasons I need to sort of run this through. Actually, here we can fix those as well. Arm, fingers, actuators. Bye bye. And that's gonna be arm as well. Odin has the same syntax for array versus slice other than the initialization monstrosity. Yeah. Yes, I believe it has. To be fair, the monstrosity isn't really something you come across in Zig. Like if we're looking for like double multiplications, I do use it in like these exact kind of places. Yeah, here we go. Some of this is like, these days in Zig you can just do that, you can just take that away. Previously you couldn't. But then if we look in the like standard library, yeah, it's used in a few places, but mostly in just like very sort of low level. Again, it's even in some tests here. Oh, that's different, and that's different. But yeah, you can do things like this. You have null writer, write yay times 10. So that would just be like yay 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 10 times, as far as I know. I think it has a proper name, that operator. Let's see. Let's see, shall we? Oh, not that, not that. Array multiplication. Yeah, like this. I'll try to make that a bit larger for you guys. So you have just importing some memory stuff here, but you have an array which is AB, and then you just take it 3 times. Then like pattern here is going to be 1, 2, 3. And of course, if you have an array, then the memory is just going to be sitting in a sequence in memory, so it makes sense that you can do it with other things as well, not just strings. But yeah, when you put it sort of all on one line, it becomes kind of nasty. Like there are a bunch of different things happening here on this one line. We have this syntax here, which we can probably find here as well. What the actual name of this is. It's used all over the place, but let's see if we can actually find a name for it. Maybe as the very first one. Yeah, well, anyway, it basically tells you that hey, make an array for me with the number of elements that I'm now going to give you, right? So this creates like a two element array, and here we have a 4 element array, and here's a 5 element array. Alternative initialization syntax. Yeah, okay, so you can just do it like this. This is the same as this. But if you don't want to count, like, okay, 1, 2, 3, 4, 5, you can just give it like, hey, figure it out for me, please. And then like length deduction or whatever it's called. So that's like one thing here. Then you have this syntax, which kind of looks pretty weird, but like it's a lot nicer when you just give it once. Just go like, hey, do that. I wonder if we can we do that? No, I don't think we can do that. We need to tell it what type. So that's like a number of something that you will have to figure out for me of the default value for mesh component data. And here is how many you should have. That's kind of what it is. To be completely fair, here I could just do undefined, and that would work just as well. But I better not use this mesh data for anything until I've actually set it up then. X asset done. Nice. Awesome. Took me a moment to understand what the actual difference was. Oh, you mean like the difference between an array and a slice? Is that what you mean? Yeah, that's a really important difference. And if someone is wondering what that is, the array is basically the memory in a sequence. And that array has to have either compile time known length or then it needs to be dynamically allocated. Let's just do this. Yeah, I had it already. So that's an array. And then a slice is literally just a pointer and a length. So you can reference an array, whether it is like an array literal, constant data, or it is dynamically allocated or whatever. You can reference that with a slice. And it's really just a pointer to the first element and then a length to know how long can we go, if we're iterating over this, for example. That would be the difference. This is a little nasty to try. I'm trying to like. Actually, that would have worked. Trying to not mess up my casing here, right? Skip those for now. Skip that for now. And we just did that. Okay, we don't have any more. I'll head off to eat now. We'll probably be back later. Back after. Well, have a good lunch or whatever it is. More breakfast for you probably, since it's always morning in Tampere. But yeah, see you later maybe. Let's see. So we have some bed things here still. Create bed physics parts. I'm just gonna call that create physics parts. That would be arm, and arm, and arm. And then truck bed graph. That guy needs to be gripper truck arm graph instead. Take that away completely. Okay. Yeah, we don't need any actuator transforms at all. That's good. That would be arm, and arm. Let's leave those for now. Arm with a big A. Armed with a big A. This is arm mass and fingers mass. Right, and here we have the input. Let's comment that out for now. Gonna get back to that later. Here we have the debug drawing. We will probably want this actually, so that we can design those collision volumes or shapes nicely. Actuators bye, and create physics parts like so, and that would be arm, something like that, right? Let's see, where is bed still? There's bed, tilt degrees. Yeah, we can leave that as it is for now. Okay, that's everything with bed. What do we have? Hatch then. I have hatch things here and there, and that's it. Okay, neat. So in the component properties, we have the arm fixture position, mesh component, and collision shapes, and then we have the fingers exactly like we had previously. We might need more than four shapes for these fingers though, so let's make it possible to have 8 there. And this is not going to be 16. I don't think we're going to have 8 either, but we can keep it there anyway. Alright. The question is, does this build? It does not. Yep, that's something we can take away. And those things as well. There we go. Okay. Coolio. So maybe I should just do a very quick run through of the articulation graph stuff. I mean, sort of talking about that without really explaining what it is. But basically what it does is does the math for us that we had to do by hand in the previous stream. And I got a bit annoyed at the fact that well, I got a bit annoyed at the thought of having to do all of that math again. So if we look at it here, it is in means_lib articulation graph. This is the code that you actually will get access to if you want to do mods for the game. So you get to use this as well if you want to do some articulated things for your vehicles or whatever. There's a whole bunch of comments here, but in essence, what you do with it is this. Let's look at the truck bed. So you have this graph. You know that there's going to be the bed, and then you have the left hatch and the right hatch. They're going to be attached to the bed. And then what you can do is you just create articulation graph. You create it right here. It's called create. And then after that you create the graph itself. So you go like, okay, we have bed. It is connected to the graph root. So create child node of graph root, and that is the bed. And then the left hatch is like a child node of the bed, and the right hatch is also a child node of the bed. And then you attach these, or sort of assign these scene node pointers like this. That's the bed, that's the left hatch, that's the right hatch. And then you can create physics parts for those. So for the bed you just create physics parts, give it the bed, give it the parent actor and how much it weighs, and then the collision shapes just come directly out of the blueprint properties. Physics material, we're just using vehicle chassis. I think we might be using the same for the arm. Let's see. The current world matrix, and then what the joint is supposed to do. So it can be linear, or it can be angular, or it can be both. And with the bed component, it's just angular. So the bed rotates around a point on the vehicle, and the hatches rotate around a point on the bed, right? So for the left hatch, you actually give the actor that we just created here in the previous part here. We give this as the parent actor, and then we do the same thing. And then the articulation graph calculates all the math for us to make this work. Then when we actually want to update something with this, there's a function called apply steering values. Here it is. So for all the values in the truck bed graph, for all the things that we might want to drive, I calculate some rotations. Again, they were all just angular here. Nothing sort of moves. Everything just rotates. And so we do set orientation in space, and this needs to be immediate true this time around. So that's why we use this thing in space here. and then this is not really related to the articulation graph at all, but we just do the same thing on the mesh. And then the magic kind of happens here in update joint drive goalposts, and it calculates the new goalpost for the physics joints. So the physics kind of move around with the different pieces, different scene nodes there in the graph. And that's really neat, because we can use this exact same thing now for the gripper arm. We should be able to use it essentially for everything. I might not redo like the crane arm just to use this, unless I need to refactor it in for some other reason. But if I make another crane, which I will, for the mother vehicle, I will for sure use this because it's just so much easier to use. And with that said, we now have triple truck arm graph, which has the same three sort of graph nodes here. Hey Sebastian, welcome back. So we should be able to do exactly the same. We have the arm, and we do have the create graph somewhere here, yes. So we need to specify this arm fixture position, which is basically like here in the middle of this thing, here inside of the car essentially. There we go. There's the here where the cursor is the fixture position. So we need to somehow figure that out actually, and give it as the blueprint property. Then this thing can rotate around that like so. The left finger's fixture position, that would be here where this pivot is, so that we can rotate this around the z-axis in Blender, but that would be y-axis in Basis. And same thing for the other one as well. And then we just assign them like this, which we already do. That's nice. And then we create the physics parts. Here's probably going to be some small changes, but it shouldn't be a whole lot. Like maybe the masses are a bit different, things like that. Actually, I think we'll immediately bring down some of these masses a little bit. Can be kind of large. And yeah, we need to set up the collision shapes. And again, they're always going to be angular, right? There's nothing moving here. There's only things rotating. So angular, angular, and angular. That would be like that. Yep, I think that is it basically. This is going to be a little different. This sort of the ranges of movement is probably going to be different. Like if we rotate this, let's say this is the rest pose, so this would be rotation 0. We can rotate it probably something like this maybe. That's like my 160 degrees. Or minus 160 degrees, but I think it's actually positive in Basis. Yep. Yeah, it's the same. It's the same orientation even. It's kind of remarkable how similar these things are. But yeah, that's the idea. So what we need to do now is, first of all, let's make sure this now builds, and then we need to go into the asset browser and start putting those collision shapes together. But what I will do now is, because we don't really have any of these fingers yet, so I'm just going to comment that out, and I'm going to comment this out, and I'm going to comment this out. Actually, that can stay. I think. Yeah, that can stay. That's just gonna be an empty array. Yep. That's completely fine. We won't have any meshes for the fingers yet, so let's get rid of that. Well, okay, I kind of changed my mind because we need to fully specify the graph. So let's actually keep these things here. It's probably fine. We will not create any physics part for them yet. I think that's the important piece here. Let's comment that stuff out. Yeah, Fingers Mask will complain about that. So that's something I want to take out, and then the meshes, because I don't want to have any meshes yet. Let's start with just the arm. That should be good. Right, and then we need to like come up with some bogus coordinates for these fingers. Don't really matter, but we still need to give them somehow. And yeah, that's it, I think. So now we need to essentially figure out this 3D position in the space of the vehicle, which is the same as the world space here in the Blender file. So that would be x is 0, y is actually this thing, just copy it into a new file again. So x is 0, y is 1.57, yes, and z is this but negative, so 2.3405. That's the arm fixture position. Good. And then what we can do is we can go here and we can copy paste this truck bed component and give it its own gripper truck arm component. And so that name needs to be the same as what we use here. Means.gripper truck arm component. Gripper truck arm. Like so. We have fixture position, bed mesh. Yeah, this is exactly the same. We just take away the actuators. And bed becomes arm. And hatch becomes fingers. Arm. Arm. And arm. Let's see if we can do it. Actually, bed and arm. Let's make sure the case entity, what is that? Preserve case. Oh, that's interesting. Let's see if that works then. I didn't know we had such a thing as preserve case, but that's perfect. Cool, and then we do hatch. Becomes fingers. So I guess it's best to just have everything as lowercase if you have that on. That's neat. And I think even our descriptions are pretty good. The position in local space of the arm when the right fingers, well, are fastened. Yep. That's probably good. Arm mesh component name, yeah. Left fingers fixture position. Let's just do like a, yeah, that is what it is. That is what it is called. Good. Okay. So now if we go into here, reload UI component definitions, and we just reload this entire thing. So gripper truck. This guy has just like a whole bunch of components already, and it will get more. So the first thing that we might want to add now is the actual mesh for the arm. So we have it here. Let's just add a preview here. Hello. And we'll do component mesh component, and we call it the gripper arm mesh. And let's fix this now directly. So nav mesh, take that away, make it dynamic, and that should be good. Gripper truck arm, and we can make it like gray, maybe just gray like that. And we can see, okay, it's in the wrong position, but we had already taken the position here, stored it safely. So boom, there we go. Now it's in the correct position. And now if we start rotating this mesh rotation around X, so 32. Oh, that's Y. Of course, 32, like this. Oh, it's actually it is negative. The rotation, yeah. So 160, something like that is probably going to be roughly the max. Maybe we can go even further. 170. Now we're actually pretty close to hitting that. So I think 160 is probably pretty good. Anyway, the rest pose is just 0. And now then, if we start, how do we do this? Yeah, okay, we need to add a new component here. So let's do gripper truck arm component, and yeah, we can leave those as they are for now, I think. And we'll quite simply, we need to give it the gripper arm mesh name. Arm fixture position is the same as that, like so. Oh, probably gonna value name too long. Oh, interesting. I'm gonna have to make that shorter then. Gripper track arm. What is the maximum for that? I wonder. Let's go have a look here on the engine side quickly. $32, okay. 33, okay. Just do that. There we go. Of course, I would like overflow it by 1. Makes perfect sense. Except we have some other issues. Okay, that's not great. That's not great. Okay, what we can do here is something like this. Because we're running it from another program, it's a little tricky. It just dies and goes away. So I have this message box call here, which can be kind of handy to use for various things. It kind of waits for us to attach a debugger. We can just attach it from Visual Studio. I guess that's probably the easiest. And when we're done, we just click OK. Oh, but it really just dies. What? How annoying of you to just die. It's not at all what we want. Take that away. Let's look at the data we have here. So gripper truck arm is here. I think it's mesh component name. Yeah. That's all good. That's all good. If we just run this, we might run into the same issue. Yeah, okay. Unhandled exception. Read access violation for set orientation. Okay. Oh, hey. Oh. Yeah. Mesh datas. Right. Yeah, that's gonna be null. That's a null pointer. So essentially it's like and is null, but of course not. So that's the problem with not setting those finger meshes at this point. Assertion failed. 275. Right, that's probably the same thing, isn't it? So we can do like if node Actually, let's not mess with that. And we can just do this instead of having this 4 here. We can just do a normal scope, and then we do const node is self.ag. Nodes. And this will be gripper truck arm graph arm index. Right. To do replace this with a for loop above. Right. No sense in iterating over those fingers since we haven't set that data at all. What? Oh, node is just okay. Node is actually just that. Like so. Hey, there we go. Okay, so this is at least how it's supposed to look with that thing. But we don't have any. Oh no, got stuck on something. We have the unstuckifier on this object, on this vehicle. Burp, just yoink it free. Yeah, we don't have any physics objects for the arm yet. There's something strange with this. I don't want to drive up hills anymore. Oh, actually, maybe we do have some strange physics going on. Yeah, yes, okay, that is the reason. Hey, there's our physics object poking through the floor. That's why it doesn't want to drive up hills. Okay, so let's go back here. Now it should work. Yeah, we can see it there. So that was stupid. So it is this thing. It is the arm collision shapes. So just move this forward to like 3, 4.5, roughly. Let's see how we want to actually do these collisions and how. What is that? Oh, it's those other ones. Yeah, okay. They show up there, but they don't get created at runtime because we commented out those things. Yeah, that's fine. That's fine. Are the vehicles using raycast wheels or physically modeled and constrained wheels? Yes, they are using raycast wheels. I'm using the so-called old physics vehicle SDK from the physics engine SDK. All right, let's see. So this needs to be very small, like 0.1 maybe 0.2 is good. Height is, well, it's more, but it's not like a whole lot of more. Something like that, maybe 3.5 maybe. One 5. And then just take it back a little bit. Maybe even a little more. Something like that. It's probably fine. I don't know. Maybe 4.4 is actually pretty good sort of compromise here. So we would actually need quite a few boxes to model this whole thing if we wanted to do that. Not sure we want to do that. Might want to just do something approximate here. Let's do one side first. Maybe the right side first. So let's see. Position. Just move that one. We get a box there. The height of this should be basically the same as that. Like that. And then the width should be that. And then the length should be something longer. All right, so let's do like 1.8, 1.7. That's pretty close. And then we need to move it down, so 1.5, 1.3. 1.3 is getting pretty close. So let's rotate around X 10, 20, 18, 19. All right, 20. I think I want to move it up just a little bit. Oh, that's the height. that's too much. Yeah, that's better. Size is almost good, but not quite. Let's do 2. Let's do 2.2. Yeah, that's pretty okay, I think. We can move it maybe a bit closer. Something like that. And then we do another one which is just like goes sort of down to that bottom one. So same one, but we make this shorter. 1.2 maybe like 41 or 50, and then we move it forward to like 5. No, that's too much. 4 is pretty good. And then we move it downwards. That's a bit much. Yeah. Yeah, we need to rotate it more. And then move it a little bit forward more. So we'll do 0.1 maybe. Yeah, that's pretty good. I think I can make it just a bit shorter, just to make sure that we don't like hit this. Yeah, that's pretty good. I think that's a reasonable approximation for an arm like this. And now we can do the same for the other side quite easily. Just copy all of these values over. And then just negate the X position value. Boom, there we go. Isn't that nice? So, I think we will give this a go. Look at that. We have our physically modeled arm there. And yeah, the physics are sort of jerking back and forth. That's because they are not interpolated. So they're running at 60 Hertz. The game currently runs at 75 because that's my VSync. So you can see the visuals are smooth, but the physics simulation is not. So far it doesn't seem to be like completely problematic, but I think I think this thing here, if we make this sort of poke down like this, that might be an issue with the physics. So I think we're gonna have to try that and add like one more of those collision shapes there, just to simulate what it would be like to have those fingers there. So let's do that. That should be pretty easy. Quite simply just take like the first one, take this one and copy paste it, and then we'll make it sit a bit lower. Yep, like that, and then we just make it shorter, something like that. Shorter still. Yep, I think that's probably good. Let's try with that. We can maybe even do a little PVD. Where's the car? There's the car. Yeah. I mean, it doesn't make it undrivable, but it kind of bounces off that arm hitting the ground there at the beginning, and I bet that might be a really big issue. So we need to think about that a little bit. Or then we quite simply, we also can't decide to like not model the lowest parts, because like the fingers are gonna need to reach pretty close to the ground anyway to be able to pick anything up, right? So how about that? That's the question. Get anything fancy from this? I guess we can get the contacts. I'm not very good at using this program. That doesn't seem to give us anything. Transparent just makes it go away. Velocity. Blip blip blip. Yeah. Gizmo scale. Okay. Joint scale. Okay, well, that doesn't help us very much. Right, so that will have to be investigated further. How big of a problem that is. Might not be a super big problem, but in the meantime, let's maybe make it so that we can lift that thing. How about that? And so to be able to do that, we need to basically add the role, the avatar role for the gripper arm, and we need to listen for the inputs, or read the inputs rather, and then uncomment some of this commented out code here. All right. If you can turn off the collision check of the ground for the grabber, you might be able to fix it. Yes, yes, it can definitely be fixed with filtering. That might be a pretty good way of handling it, because you almost certainly won't want to actually grab the ground. So that might be a pretty good way of fixing it. I do wonder if I have the rest of the environment set up to handle that though, or if I have to go in and just filter out a whole lot of things. It would also be kind of sad to have to do that. I wouldn't want to do that if I didn't have to. Because, like, okay, first of all, that would just make the arm go through the ground visually, and that, of course, isn't very cool. The other thing, which is also kind of a coolness thing, is the fact that, like, so far with all of these things that we have here, you've been able to do things like this. You can just like lift the whole mother vehicle off the ground almost with by just pointing this. Like I'm not pressing any like acceleration or brake or anything like that. We're just like dragging this thing with by poking at the ground with it. Right. It's maybe a poor example of this. If we drive a bit closer to that, like somewhere here actually. Yeah, we don't really have enough height differences here in the ground, but you get my idea. And so it would just like go through the ground, and that would look kind of nasty, I think. So it would definitely fix that issue, yes, but I think it would bring more issues than it fixes. Potentially, I don't know. So let's try to not have to do that. That is sort of the sledgehammer way of handling the problem. And add to that the fact that like a lot of the static objects in the scene use the same physics material as the ground. So I would have to go in and separate those out, which I kind of really don't want to do. Anyway, the first thing we should now do is go here to the, what is it called, means vehicle, here we go, vehicle avatar component, and add, what? Why is it jumping? So truck bed, I think we'll put that as truck bed, and with the second one as gripper arm. Right? Gripper arm sort of, it makes sense that it comes before truck bed, I think. Right. And with that we should just be able to access that menu. Right? So now we have three here. Gripper arm, truck bed. Truck bed still does what it's supposed to do. Yay! And gripper arm doesn't do anything, and you can't drive or anything currently. Just access the radio. So this is now where we would be able to lift up that thing. Truck bed down. Driver. Yeah, there's the first vehicle with three rolls. And we have one more roll that we can add, and then I'm going to need to add scrolling support to that menu. Maybe we don't need to have 4 rolls for any vehicle. We'll see. Input. So we have something called gripper arm. Open fingers, close fingers. Rotate forward, rotate backward. I think we're going to use those. And then those. Move forward, move backward. We don't really have that. The gripper vehicle itself had like, well, its arm looked different, so it had more movements it could do. But basically, those vertical rotate. It's, the name is a bit funky, but let's not worry about that. I'm just gonna take that thing. And copy it there. So here we have arm rotation speed, finger speed, maybe finger speed is, oh, there's an extra A there. Something like that, and then finger speed is that and that. And again, we already made it so that X is the arm rotation, Y is the fingers. That should be good. How does this work now? That's a state, good. And that's a state, also good. Excellent, so we can just do rotate forward. I think that's that. Rotate backward is that. Oh. And then open fingers and close fingers. And we can take that away. That should be that. Arm rotation speed. And then we need to go into apply steering values. So max bed tilt degrees. This would be max arm rotation degrees. We should probably also have a minimum, and I think minimum was it minus 160? I may be getting this wrong now, but let's say it's minus 160. Maximum would then be like, I don't know, 10 or something. And here we want to basically do this. We do degrees is let's do basis math, remap float, tilt amount, min arm rotation. No, sorry, 0 to 1, min arm rotation to max arm rotation. Rotation amount. Right, and then that's that. Essentially. Hatch open amount, that would be fingers open amount. Max fingers open degrees. Yeah, maybe something like that. I think 90 is maybe a bit too much. Let's make it like 70. Whoa, hey, whoa, hey. That's not good. Let's see. All right, oh. Yeah, I see the problem here. I see the problem here. Let's flip these around actually. Max would be 160 and this is just 0. See what that gives us. I don't know which way these yeah, okay. Okay, this is actually kind of what I was like trying to accomplish from the beginning. So I think that's probably a pretty reasonable max rotation. And if we enable the physics visualization, we should see the shapes move there as well, which we do. Again, it's a little bit jittery there with the visualization, but looks pretty good. Okay. And this should now actually then affect things. So if we add like a pile of things here, these big crates. Then we go to driver, drive really close. Kind of doesn't look like it's doing anything. Let's see. Gripper arm. Oh, it is actually. Yeah, it is. It's a table flipping device, basically. Yeah, this is the sort of thing that I was talking about there. We can do like burp. You can do things like this with the vehicles now. Now I'm stuck. I'm stuck probably. Yeah. Get the unstuckifier. Burp. Doesn't even work. Okay, that's strange. That's strange. But yeah, I do like the table flipping aspect of this. Take that away. Just arrive somewhere and go. Screw you guys. I didn't flip any tables this time. Let's take this to another level and see how big of an issue that front piece there is in something like we can take it to the demo level. Just do a gripper truck there. Right. I think depot might be even more sort of mountainous and uneven. This has a lot of really kind of green, wide open spaces. Yeah, I think the way it's sort of felt is just that it's a little more bouncy than it otherwise would perhaps be. Which may or may not be an issue. I'm not sure it's an issue, but it might be. Bonk, like that. Like you're not even hitting the suspension at all. You're just bonking. And then we can of course just lift it up a little bit, and now we can drive it like this. Bonk. Yeah, I don't know. Might not be a big problem, but I'm gonna have to perhaps play a bit more with this. What if I put some cargo in the back, and then I drive around recklessly? Reckless driving. Put some of these guys here, and then put some of the smaller ones. Maybe some spheres, why not? Spheres. You know, the default position of the grabber in the back. Yeah, I mean, nothing prevents you from moving it somewhere and leaving it there, right? If someone gets annoyed with the fact that it's in the front, they can just do this. But I think it might be annoying to have it there, right? It's kind of a little bit in the way, blocks your view and all of that, and also it kind of like looks funky. But I get what you mean. Like the default would be where it starts, and the default would also be where you can reset it with by just pressing a single button. Should be able to reset both the bed in the back as well as the gripper arm with a single press of a button. Oh shit. Oh, that's gonna be the end of my cargo. No, just one. Okay. Yeah, like don't mess around with the arm while you're driving. Now, if only we had those fingers attached, we could lift up this and throw it in the back. That's gonna be fun when that works. Give me your cargo. Yeah, I don't know. It's not necessarily as big of an issue as I thought it would. So that's good. Might not be quite as big of an issue. Let's go somewhere where there's even ground. And I think that would probably be inside of the base. So let's open the main gate. Whoa. 2 visible items with conflicting ID. Oh. Huh. Yeah, probably. probably right, yes. I need to make that unique somehow. Right, so here is here's even. Here's flat terrain basically. Especially if we drive into this, should be completely flat. And again, you can see what happens when you have light probes versus not have light probes. Those two boxes in the back have light probes as well as all the other dynamic objects, and the truck itself does not. So, like, if we should be able to pick up, let's say, that thing, then the physics would have to be, the physics would have to be even sort of a bit lower than what they currently are. You can see that this is where physics for this current setup ends, and if you consider the fingers to be roughly here, then that's not a lot to grab onto this box. So I think we should make it so that it can turn even more than the standard 0. So 0 would be 0, but if you start and you lower it, oh sorry, hitting the microphone here. If you lower it from the starting position, it actually sort of points down a little bit. If that makes sense. Let's do -5. Where does that take us? Yeah, now it's pointing down. We want it to be more than that though, for sure. Let's do 15. Yeah, okay, well now it's essentially lifting the lifting the thing off the ground slightly. That's not good. You can see it sort of jumps when it hits the ground. Bonk. So that's not good. Let's not have that. Maybe 12. I don't know. I have no idea. And then of course we need to somehow make it so that that 0 is 0. Like 0 is 0 degrees. An input value of 0 is 0 degrees. Yeah, now we're not hitting the ground anymore. Now it's probably kind of annoying to drive, isn't it? Yeah, now we get stuck super easily. But that's fine. I mean, if it is kind of, I don't know what's happening now with this. If it is kind of semi-easy to drive in the standard position, and then you can go in and lower it from the standard position. Let's say standard position is here, like that. And then if you can go in and like lower it like that, then that's probably fine, even if it makes it super difficult to drive. It's kind of like the same thing as just poking at the ground with the crane, the mother vehicle's crane. I don't really have an issue with people having problems driving this if they do that. So that's probably fine, but we need to default it to, you know, the standard, whatever this is, that kind of thing. Yeah. Yeah, I think something like this would probably work. Let's see. Let's try to figure out this math here with the remapping. It's honestly like a little hard for me to wrap my head around. We have the value of 0 here, and we have the value of 1 here. And this would be minus 12. And this is the, what was it? 160 is here, right? Now here about there it's 0. And so what is that? Because this is like the default steering. As the default steering, what that is, steering value. I was thinking of how do we set this up so that it's easy to tune later on. You don't have to do like a whole bunch of remappings everywhere. Or would it be easier to have this as 2 separate ranges? This would be one range, and this would be another range, sort of positive range. That means that we could even have multiple ranges with different speeds, like this. So have like the safe range here, and then when you're approaching the ends of it, it kind of slows down. Something like that. But I guess we can always just calculate this value. Calculate that value out of the range of this. It's not minus 15, no. It's going to be something like 0.1. No, it's not that. If we take these, we just move them up here because we're going to have to calculate this. So if you take 160 minus 12, that would be 172, right? So 172, let's see, we can have this 160 minus 12 is 172, and then we do 12 divided by 172. This will give us 0 up here, right? So like the math is not a problem, but what is the easiest way to tune this? But maybe we'll do it like this. I don't have a better idea, or I have a better idea with the different speeds and everything, but maybe we don't need that. So let's do min arm rotation, max arm rotation. We should be able to just calculate that at compile time with Zig, which is nice. So that we can give it there in this. So let's just do function default arm rotation. Actually, we don't need to calculate. We can calculate it. We can do it as a constant here, right? Default arm rotation steering value. And what did I say it was? It was like, can do it with a block probably. Can we have blocks here? I don't know. Unused block label. Okay, I'm gonna do it. Don't stress about it. Actually, that's probably needs to be a comp time float, but let's let it figure it out for us. So if we have the same thing here, we take the max minus the min. Max minus min is that. That gave us 172, and then we do break BLK min divided by max minus min. Yeah, and that becomes a comp time float exactly. So this thing we can now chug into here and here, and that should give us a nice even default arm thingy. Min arm rotation degrees, max arm rotation degrees, and of course, oh no, this is actually quite okay. Yeah. Yep, that's good. Maybe we can just min arm rotation degrees. I have a habit from like my C++ days to do constants like this. Something like that. Let's try that and see what happens. Use of undeclared. Oh, right. the same thing here. Max fingers open degrees. So, okay, that didn't work. Is there something wrong with my comp time math? Yeah, it went to 0. Why? Why? Let's print this guy actually. Basis printf default value. Let's just make sure that I have this Zig syntax figured out, right? I'm not a mathematician. Yeah, neither am I. Neither am I, but this shouldn't be tricky. It's just that I'm probably doing something stupid here with the... Oh yeah, -6. That's not good. What did I do? What did I do? Did something stupid. Let's look at our Python code again. Max minus min. So max minus that. And then we take min divided by that. What? Why does it become -6? What is going on? The result. Oh. All right, what do we have? Oh no! It is actually, yeah, okay. I didn't see there was an E. There's just using the scientific notation. Okay. Yeah, okay. I should have done this. Let's get rid of that stuff. I should have done like D:0.5 or something. Something like that. So we're expecting to get 0.06976 maybe with this. Yeah. Oh, except it's a negative. Negative? What? Well, that would explain why it doesn't work. Why is it negative? What? Let's take these back and add that to all of them. This minus this should be positive. And then we have, oh, what? But that is negative. Jesus. Okay, you can just I don't know, blow me out the airlock now. You can just blow me out the airlock now if you want. Yeah. There we go. Over then straight. Right, and OBS is unhappy with me again. Let's hope it's not a big problem this time around. Right, I need to not select things. Okay. Okay. So now that I've embarrassed myself with my math, what is the next thing to do? Min arm rotation degrees. Maybe we should move the finger degrees there as well. So we have all of them in one place, right? Arm mass and fingers mass. We can maybe even move those here. Arm mass. Fingers. Oh. Fingers mass. Arm mass. Fingers mass. Like so. Alrighty then. Let's add a comment here that arm rotation 0 degrees is the rest pose. Negative angles means facing down from the rest pose. So that should kind of tell, well, me half a year from now when I'm reading this, that what does it mean? What does it all mean? And now if we add one of these, let's see, small boxes here, one of those. Drive a bit forward like so. And then look at that. Yeah, that's gonna be good. Gonna be real good. You get stuck with this now here. Then you can lift it up and then you're good to go. I kind of feel like I probably need to port my custom differential from physics 4 to this though. Because this card just gets stuck kind of easily on small sort of hills like this. It's kind of difficult to see, but like this wheel is just spinning wildly in the air now. that I'm holding the gas, the accelerator. So I made for physics 4 actually a custom differential that kind of divides the torque a bit differently and tries to favor wheels that have more compression on their suspension, and it handles that beautifully, that case. Okay, let's try the depot level with this and see how badly it gets stuck there. Yeah, it immediately kind of bounces off it, clearly. So like if we lower it down now, I don't think we can really drive with this at all. Well, no, very poorly. Very poorly. Okay, so let's reset it. Something like that maybe. I think that's perhaps about the standard. Yeah. What's the problem here? Why can't I get up this? Strange. I don't think that has anything to do with the arm. Looks nice. Well, thank you. Thank you. I hope it does. Yeah, I need to look into that differential stuff clearly a bit more, because there's something funky going on here with this. Kind of gets stuck in places where I feel like it shouldn't. It might also be like an engine power thing. Let's see how much engine power this thing has. There's something that we can tweak here while the game is running. So means data, work folder, game, vehicle diffs. So the Scout has engine max rotation speed 400, engine max torque 600. Gripper truck has I just wanted it on this side. 1200. So it's, yeah, it should be pretty good. Yeah, torque vectoring is the thing that I spoke about, but this doesn't work currently with physics 5. Yeah. Yeah, it's pretty sluggish. But maybe it needs to be sluggish. Maybe we need to let it be sluggish, at least in certain situations. It is a truck after all. Oh, we have grass inside the house here. Maybe we should fix that. Maybe that should be fixed. Like interactions like this should work kind of nicely. Like you can sort of hang on to another vehicle's arm with your own arm if you want to. Boink. And I sort of feel like we should have that in this game. This game should be all about that sort of stuff. Things that games don't typically do. Because they fear it is gonna be janky and wonky and look silly. And I think we need to embrace that with this game. Not care if it's janky or wonky or silly. What happens if I do, let's see, do this like that, and then I close the truck bed? Yeah, those don't collide, but that's probably for the best. And I think they don't collide because specifically, like they are attached with, they're attached to the same physics objects. Oh no, I'm talking out of my rear here. It's actually just about not colliding in the current state, but they probably will when at least there will be overlap when we add the fingers there, right? Yes. Oh well. Yeah, well, this is coming together. There are some issues. that I need to solve. Some of them technical, some of them design issues. But I'm kind of rapidly approaching a state where we have this vehicle fully functioning with its 2 articulated systems, so that's nice. And then of course I need to texture it, and I need to add sound effects and particle effects and tire tracks and SDF lighting volumes and everything. Oh, now we're stuck with the arm probably. Whoop. Oh, that's one way to get off it. But yeah, this is coming together. I'd say this is coming together. 4 hours is still live. Indeed, yeah. This is not even close to my record. I think I've done like 10.5 hours or something. That was my record, and that was pretty that was pretty rough. Yeah, I'm contemplating whether or not I should continue streaming today or not. Basically, I need to get those fingers working. Add the gripper, basically. Hello, Arcane. Welcome back. Glad to have you. However, I've been doing this for a while, and I'm wondering whether or not I should continue doing this today or not. If I should just do a little bit of work offline, or would you guys be interested in following along if I continue working on this thing, which I can do. We can get the fingers working, and then we can lift things and deposit things and do all sorts of things with things. But I could also just do it offline. I don't know. What I do know is that I'm probably gonna have to take like a little bit of a dinner break in a little bit. I have to watch a 10-hour stream as well. I wonder if that was any good. I don't know. OBS is once again disconnecting and reconnecting so fast you don't really have a chance to even see what happened. Yeah, okay, it was a cargo crane stream. Indeed. This thing here. Yeah, this is 10 hours. Oh, it's not 10.5. It's 10 hours 5 minutes. Yeah, lunch break. 0 to 2. I'm just gonna shut myself up there. Yeah, but we did the movement limits for the crane. Indeed. movement limits for the crane, so that you can't move it into like absolute crazy positions. Yeah, it was a good thing. I don't remember if the stream was any good, but the system turned out pretty alright. What's a launch? Not launch, but lunch. Lunch. The kind you eat. That kind of break. And what then? Then I did some texturing. Yeah, okay. Yeah, I think I textured the whole crane. So in the end it looked like this. Kind of like it does now actually. And in the beginning it looked like this, without any textures to speak of. Yeah, that was 4 months ago. Others. Alrighty then. Oh, 1 second. Phone call. All right. I think what I'm gonna do is this. I'm getting things done quite well today, so I might want to capitalize on that and just keep going a little bit further. So I'm gonna work a little bit more on the gripper, most likely. And you're welcome to tag along if you want. But I will take a break in about 10 minutes or so. Go make a bit of food. And then after that I will create a new stream, probably. So if you want to tag along in about an hour or something like that, then stay tuned. We'll keep working on the gripper a bit more, and we'll try to get at least like a first. Yeah, look at this. Like what is happening now? I think it is. Yeah, it's that wheel spinning like crazy. I should really like I should do something about these wheels as well. You can see it. You see it a little better when you have these visualizations on. These wheels are so nondescript that like you just get stuck here. There's a wheel in the air spinning. But yeah, I'm gonna try to get at least like a first version of this gripper arm done today, so that you can actually grip things. And that involves basically looking at the gripper vehicle, the old one. Did you eat? No, I didn't eat yet. No, not yet. Yeah, gripper. This is the old gripper. And this thing can lift objects. It's a bit fiddly, but it can lift objects. Kind of like this. Whoop. I'm gonna try to do something like this with the truck, right? So that the truck can do sort of the same. We can load these into the truck like this. No, no, so close. I don't know how I managed to screw that up. Didn't have my handbrake on properly. Yeah, the handbrake is also fiddly. It needs improving. Surprisingly difficult to get the handbrake to work in some situations. Like that. All right. Oh, the handbrake sort of disengages by design, sort of. In certain situations, turns out it might not actually want that to be the case. All right, what do we have now then? Again, something is just spinning. Yeah. Wonder if we should actually start by just reintroducing that torque vectoring in the evening stream. Or not. I don't know. Maybe the gripper arm is good to get out of the way, and then I can mess around with that later on. But yeah, something like that. I think that is the plan for tonight, or depending on where you are in the world, later today. And one way to get notified of that stream is to join the Discord, where we'll get pinged whenever I upload a new video or a stream. Another way is to subscribe to the channel and click the little bell icon. And that supposedly also pings you somehow. And look at this, it's so slow. Oh no, what is going on? I do wonder if like, up, brake. Let's see, spring strength is ridiculously high. So let's make it a bit less so. this is the deal with like creating a physics-driven game, is that like you're designing a vehicle and then you're like, oh, okay, I need more strength in the springs because like I can't like the suspension gets compressed too much. I can't deal with this. And then you add that, but actually, in fact, it might mean that the cargo is too heavy. So then you go and adjust the cargo, and then it causes some instability issue somewhere because you have like too big of a ratio of masses between two different objects or something. Everything is connected. Whoa. So slidey. I will say that it's pretty fun to drive around with this thing and deliver cargo and pick up cargo, and well, I haven't been able to pick up cargo yet, but I've gotten cargo from the gripper. So that's a good sign. And yeah, we definitely need to add that reset articulations. It's just boring to have to wait for these things to close again. It also kind of feels like it maybe doesn't get stuck as much if it's empty. So maybe just something there with like actually carrying a lot of cargo in it, and it's sort of making it get stuck more easily. I don't know. May be the case. Yep, alright, it won't change from this currently. Right, I am going to end this stream now. If you like what you're seeing and you want some more of it, you can have more of it in an hour on this very channel. So do join me if you wanna hang out a little bit more. Regardless, I thank you for your time today, and hope to see you later.